I've characterized this before as everything in 2D to me feels overhyped. Voice, video, image, text, it's all going to continue to improve somewhat incrementally, but it's good enough. You're going to reach an asymptote of good enough on all the two-dimensional stuff. Today, with one-shot learning, meaning maybe 30 seconds of audio, 11 Labs or some of the other voice models can capture you with an indiscernible, probably 90% similarity. Maybe your spouse, your loved ones, your families would be like, it doesn't sound like him. But the vast majority of these things are getting so good that with very little training, they can emulate and predict and do all the things that are of high utility. What's scarcer is the three-dimensional world, particularly robotics and biology, in part because you have large unstructured data sets. A robot walking in and figuring out how much force to use with this cup 30 minutes ago when it was full versus now when it's empty is something that we all do intuitively the second you grasp it. You know exactly how much force to use so that you don't throw it over your head or have an inability to lift it because it's too heavy. All of that kind of training is really scarce, and there's very few companies that are doing that. So the entire robotic ecosystem, from the embodied intelligence and the AI models and the world models to the motors and the gears and the supply chain for that, mostly domiciled in China, is a big area of opportunity. The other big area of opportunity is biology. Being able to go from a prompt to a protein, to be able to design a drug. Biology is really complicated. Computer scientists often underestimate how hard biology is because they're used to 2D linear inputs, outputs. Here's my code, it works. But biologists, on the other hand, also massively underestimate how sophisticated computer science has got.